presentation about digital twinning in manufacturing.
Right, I hope everyone can see my screen, see
Yes.
me, hear me. So that's good. All right, I'll give a brief introduction to digital twins in manufacturing. And why we do this, I notice a lot in talking with SMEs and other companies that they find it very difficult to understand what a digital twin is, and that makes it very hard to discuss how it will bring business benefit or where do I buy parts that I need to make it work. So for that, we have this brief introduction to get to a common understanding of what digital twinning means. And let me just guide you through here. So I'm Jeroen Broekhuijsen. I'm a business consultant at TNO. I've been doing digital twinning for 15 years, and I'm the technical coordinator in Change to Twin. After this talk, we will have covered what a digital twinning is, how digital twinning fits into smart industry, how you can explain digital twins, and how you can link digital twins to business value. Everything in my presentation will be available, and questions can be asked either in the chat box or in the end. And if you have any other questions, feel free to email the Change to Twin project. So first, I need to explain a little bit about smart industry, and then I can dive into the actual digital twins and then explain a bit how you can apply them. So the context we're in is in manufacturing, and many of the developments are about smart industry or Industry 4.0, as they call it in Germany. And the real question is, what do we mean by this? And in Germany, they've created a nice graph that shows the maturity level of companies in manufacturing and the different stages of either digitalization or smart industry. And when we talk about digitalization, we talk about the process of applying digital technology in all of the company processes. And when we talk about smart industry, it's about connecting products and machines and people to produce in a smarter way. And if I then look at the maturity levels, many manufacturers have computers, they use IT systems. The next stage is having those IT systems connected, also, for example, to ERP systems or creating work preparation. So almost no longer working on paper. Then the next stage is monitoring, where you can get feedback from the manufacturing process in how things are going. And if you're making the planning, those kind of aspects. And then can you use that data to understand what's going on? That's the level 4 of maturity. And if you can then understand what's going on, can you predict what will happen next? And that's the 5th level. And if you can predict what will happen next, can you then adapt and change according to what's happening in your factory? And that's seen as the most mature level of smart industry. So how does digital twinning tie in here in this digitalization or smart industry? Digital twinning is on the right side of this maturity levels. And because if you don't have data, if you don't have feedback, and you don't know what's going on in your factory, it's very hard to create a digital twin. And the problem is that if I look at innovation, we always say we want some kind of self-adapting or autonomous factory, but most of the companies are only just starting. And that's one of the biggest barriers in adopting digital twinning technology, because first you will have to make the step to level 3, as seen here, to really start with digital twins. Oh, then what is a digital twin? And first, I need to explain why we want to have a digital twin. And for me, it's very simple, because we can't or don't want to do something with the real object. Just as an example, I was talking to a manufacturer who had several machines, and the trick was, what will happen if the machine breaks? And he didn't really want to break the machinery they have, but they could break it virtually, so digitally, using a simulation, using data from the actual machine, and using the knowledge from the domain experts. And that means it's usually better, safer, and cheaper to do something digitally compared to doing something with the real thing. So you can use it to lower your risks or get better understanding, or maybe make something more effective, all kinds of applications that you can do with a digital twin. And what's different from before, it's become far simpler to use models and simulations in all kinds of business processes than before. And the goal of all these models and simulations and this twin is to create actual business impact. I've had too many companies ask me, oh, I want to create a digital twin. And then I ask them, do you know what you want to use it for? And they say, I have no idea yet. And then I always say, okay, go back and first think about how this can create business impact in your organization. And that's also something that we tackled in Change Your Twin with the assessment process. For me, a digital twin is a digital replica. So it's a, let's say, a copy of something real that's being able to run on a computer. And that copy should be good enough to take some kind of action for a specific purpose, whether that's doing quality inspection or real-time planning, or it's about customer engagement. All kinds of purposes are there. And I want to take some kind of action that brings me as a company value. It's a means, not a goal by itself. And it should create value by linking the data, models, and the business processes together, because that's what smart industry is all about. So when we talk about this replica, the whole goal of this copy is to be representative enough of the real thing. And that means it needs a certain degree of accuracy. It needs a certain degree of behaving similarly. It needs to have a certain scope, a certain level of detail, and a certain level of timeliness. For example, using data from 3 years ago might not always be the best solution if you want to do some real-time inspection. And not every question, not every purpose will need the same accuracy or same scope. And so there's a trade-off between these parts that make the twin representative enough. And the more knowledge we can embed into the twin, so the more useful the twin can be in the future. So breaking a twin down into its parts, when we talk about twins here, we're talking about replicas. And so here, I'm not sure if you see my mouse, but so when we have the noun of a digital twin, we're talking about these different replicas. And there can be more than one. There shouldn't be a single twin to rule them all. Different purposes require different mechanisms, different types of modeling or simulation, and that means different types of replicas. And they can coexist next to each other. So for a single machine, you could have 3, 4, or 5 twins running in parallel. These replicas require data to make them work. Sometimes real time, sometimes from last week, sometimes from last year. It depends on the purpose what you're using the twin for. And a replica and data by themselves can't do much. They need an application to link everything together. And let's call that a digital twin application, which is software. And then if we switch to the right side of this diagram, we have the paradigm. So the concept of how we're talking about digital twins, which is usually a combination of data, one or more replicas, and an application. So when we usually speak about digital twins, it's this combination that we're talking about. And that actually is for a specific purpose with specific accuracy and a specific set of data. And to make that work in the organization, it's not just I set it up once and then I'm done. There needs to be a life cycle, because if the machinery changes, if the product changes, the twin and replicas should change along with it. So the digital twin also has a life cycle similar to the real thing having a life cycle. And that's what we call with the verb digital twinning. How do you then apply these twins? What we've discovered in interviewing many companies and also trying them out in the pilots and also with the first rounds of open calls, we've come up with these, I think, 11 or 12 purposes what you can use the twin for. And that ranges from engaging your customer, showing them the 3D model of your machinery, for example. Maybe it's a modular configurable and the customer can change options on the fly and see how this machinery fits into their own factory. So that could be a use for a digital twin. At the same time, we can use the twin to virtually design the next iteration of my machinery. So we can make any kinds of design choices that will affect how the machinery works, how it operates, and maybe we can gain new insights, which we can then use to provide feedback to the engineers and get new understanding of how the machinery actually works. Maybe we can digitally commission the machine in the customer factory without actually having the machine there. Can we find the right parameters using all kinds of simulations? And also, if we have it in operation and it works, can we then monitor if it's behaving according to spec, if the quality is right? Maybe we need to optimize some parts, or if it breaks down, can we do diagnosis and then have the right outcomes for the maintenance teams who needs to either maintain or refurbish the machinery? And on the other side, can we maybe train these engineers with the machinery without having the actual machine there? So in a virtual environment. Or, as I already said, with logistics and planning, can we ensure that if there's any disruption in the whole factory process, with parts missing or substances missing, can we reschedule in real time and predict the behavior of the factory? And lastly, if we sell maybe machinery or products and these products or machines are smart themselves, can we sell the digital twin along with the real product? So all kinds of applications where we can use the digital twin in manufacturing. We've had 4 pilots in our Change to Twin, and now there is, I think, 15 of the first phase of open calls are starting. I just highlighted the 4 pilots here. So we have spray structures. They're doing virtual design where they create 3D printed biomedical devices, and they use the digital twin models to improve the design of the biomedical device. They did actual 3D printing of the parts. They did testing and quality inspection of the part to see if that matched what the design said it would do. And can you then learn from this whole cycle and get new design rules to better improve the design phase of your product and get to, let's say, first time right design of biomedical devices. The other example is RoboPack, where they used it for commissioning, where they wanted to ensure, so they modeled the pallets and products on a pallet that are wrapped in cling film to ensure that the transport movements would and the actual placement in the warehouses, that the packaging material would keep the whole pallet intact while using the minimized amount of plastic. So they modeled the behavior of all different kinds of materials which are put on a pallet and see which amount of cling film is needed to create the correct wrapping and then simulate this whole structure and also do physical testing to see if their predictions are correct. And now they have estimation twin, which is part of the cling film robots, which is able to calculate if the amount of cling film will keep this pellet intact, yes or no. Two other examples. One is Additive Industries, and they are a metal 3D printing company, and they used the twinning mechanism to do inline inspection during the 3D printing process, where for highly complex 3D printed products, they can reconstruct the 3D shape and also correlate this with the laser quality and melting quality of the 3D printed product to see if there are any defects during the 3D printing of the actual product. And this means they can either correct the effects in production, or they can preemptively stop the production process because the defect is too big to be manageable. Another example is Grafenstone, and they used a digital twin of the manufacturing process to see which order is where in the process and which materials are needed. And so they focused on the planning and logistics phase of their manufacturing to use the digital twin there to better keep track of what's happening and to be able to predict which kind of paint will be ready on time for the customers, yes or no. And what we also discovered there is that twinning involves more than just creating the twin. There's all kinds of organizational aspects, new ways of working, and it requires a heavy use of digitalization and data-driven working. And the main importance also is that companies need to apply the results of the twin in the organizational structure. And this usually takes more, just as much effort as creating the twin itself. So what we see in twins is that there are multiple expertises needed. The domain experts, business experts, IT experts, and data experts, each having their own knowledge and role in the whole twinning process. And of course, the twinning experts that know about how to create twins and increase the capabilities of companies doing this. And if I look at the digital innovation hubs and the experts they have, I think you can play a linking pin to link all of these experts together and to ensure that companies can actually make it work. What we also see is in that there's different maturity levels of companies that want to adopt digital twins. So for just this is from the OMG Digital Twinning Consortium, which created the first kind of draft version of digital twin maturity, and they have these different phases of how ready a company can be for a digital twin. And for example, dinosaurs usually are looking to buy a solution and then be done. But in practice, this usually doesn't work. And what we see is the majority of people who are now actively developing digital twin are leaders, and they understand that this is a core business strategy to have this twin in their company. And so this would be a major change. And I've been working with several companies already who are even beyond there, and they're looking, how do I need to transform my organization to have multiple twins linked together? And how do I ensure that everyone in my organization understands what twins do and how they are part of our core strategy of the company? And so there's different needs for different maturity levels of companies. And when you're starting the whole journey of digital twinning and you have an idea, I think that's where Change Your Twin comes in with the current innovation vouchers. First steps are, I need help understanding what a digital twin is. And then we can do the assessment, tie the digital twin purposes to business KPIs, and understand how they can help the business of a manufacturer. And then we can identify what the manufacturer really needs and find partners in the marketplace or elsewhere in the region. And we also do helping, guiding the implementation in our mentoring program and evaluating how things went. So the whole journey from start to end is what we're trying to cover in Change Your Twin. So in summary, for a common understanding, a digital twin is a digital replica. It should be good enough to take action for a specific purpose. It's made of data, a replica, and an application. It needs to be representative enough for a specific purpose, and it should create business value and involves more than just having the twin itself. And depending on your already existing digitalization level, different purposes for your twin might be possible and different values can be possible. And lastly, prepare well and get support if you need it. All right, so I think that's it from my side. And later on, I think my colleagues will explain even more and give some practical examples from the companies I've just shown. Any questions currently?
Jeroen, there is one question. Do you have catalog of digital twin solutions, pilots for SME?
Yeah, that's being worked on right now. We already have a catalog of several solutions in the marketplace. We have the pilots descriptions that also have this catalog, and we're using the open calls, the first round open call participants, and to further increase the coverage in our catalog. And there is also some other bodies who are developing something similar, but it's too early yet. But it's being worked on.
And second question, what is most popular application software for digital twin?
Yeah, it depends a bit on the focus of a company. Some companies focus more on the R&D and design aspects, like space structures, for example. And their work ends when the design is ready. And other companies focus more on production. And they usually want to do optimization and planning reconfiguration. And other companies focus more on creating unique products, and there usually the quality inspection is crucial. So I think those three are the most common applications. And then the fourth, which I'm currently seeing, is for sales divisions of companies, that they understand that they're switching from unique projects to modular configurable solutions. And then they have a kind of solution where together with the customer, they can design their modular equipment in a certain way. So I think those 3-4 are what's most common with companies.
And another question, is there an overview of known ways to retrieve data from machines?
Yeah, it doesn't cover everything, but there is an overview. It's not in this presentation, however, but I can share that if you want.
There is one question about the availability of a catalog, but yes, we can. I think we can share the catalog. It will be sent after the webinar with all presentations.
Yeah. All right.
Thank you.
No more questions? All right, then I'll hand over to the next speaker.